Hello, my name is Gregor Hofferbert. I'm Field Applications Engineer at Teledyne LaCroix, and I'm here today at the PCAM exhibition in Nuremberg, and I want to show you our double pulse testing setup. We have an instrument that's our WavePro HD instrument, goes up to 8 GHz of bandwidth, and we have up to 5 gigapoints of memory, and we have real 12-bit vertical resolution, so we have really 12-bit ADCs inside the scope. Besides that, we have a signal generator, the T3AWG, and with that generator we can create the double pulse waveforms to control the switching devices. We have here a small board, that's a demo board we use for showing these measurements, and we can control the board using the generator, and then we measure the signals at the board, at the switching device with the instrument. For measuring, we have different probes at that setup. So we have one probe, that's a small one, that's a differential probe, the DL-HCM. That's a probe where we can measure the low side gate. It goes up to 1 GHz of bandwidth. Then for the high side gate, we have the optically isolated probe, the DL-ISO, which goes up to 1 GHz of bandwidth and up to 2.5 kilovolts. For the gate drives, for the gate measurements, we have probe tips which are connected via MNCX connectors. They go up to 200 volts. And for higher voltages, we use these connectors directly to strap-in connectors for 1000 and 2.5 kilovolts. And then on the scope itself, we have a software we call power device measurement, where we can make the measurements associated or defined by the JEDEC. JEDEC gave the proposal how to do the double pulse measurements, and we follow these proposals. But as user, you have also the choice to change the levels. You want to measure your turn on, turn off delays so you can decide how to do that measurement on your own. And with that software, I think we should go now to the scope. Here you see our power device software solution. You have the input, that's the main menu where you see all the measurements you can do. So we have the delay measurements, we have the loss measurements, and finally reverse recovery. With the input stages, you can decide which probe shows what signal. You can make the fine correction of the skew between the probes, and also the fine correction of the offset. With that value here, you define the region detection. So you measure on the drain source voltage. You measure more or less the 50% point to define the single switching stages. We can measure at the same time up to 5 double pulses with the same measurement, and so you can show these regions. The scope detects these regions and shows them for you on the screen. If you want to, you can switch it off if you don't like it. Then we can go into these measurements. As I said before, we follow the proposal from the JEDEC. If you go to auto measurement, the values where to measure the delays are set to the JEDEC proposal. Otherwise, you go to manual, and then you can select individual values where to make your measurements. If you switch on the help markers, you see also the voltage levels where you measure on the signal, and you can even click here and move these values around to the desired position on the screen. Then you can decide on what region you measure, either if you measure all or just a specific area where you want to do the measurement. And finally, you can click also. You can show how this value change over time. If you click here in the table, you see how that value changes over time. You get a distribution or a view how your switching device behaves. So that's now an acquisition where the current is increasing over 5 double pulse tests. Here we have the differential probe, the DL-HCM. DL-HCM means high common mode, so we can measure 80 volt differential and on a common mode of 60 volt with a common mode setting of 60 volt. So that probe is designed for measurements in automotive market, because where you have the 48 volt different systems. So that's one probe. Then we have here a current probe, the CPO30B, where we can measure currents up to 30 amps RMS and up to 100 megahertz of bandwidth. That's a probe designed for measuring the currents in your system with high frequency content. Then we have the DL ISO probe. For the DL ISO probe, we have different probe tips depending on the input voltage range you wanna measure. So this tip goes up to 10 volt, up to 200 volt. We use the MNCX connectors, which are more or less a standard in that area where these connectors are used. If you need to measure with higher voltage range, you have these scrap-in adapters, 1 kilovolt or 2.5 kilovolt. That's a complete optical isolated probe. That means we have here an optical powered amplifier in the probe head. Where we modulate the signal on a fiber, on a laser, and transmit it via fiber to the scope, and then we are completely isolated and can perfectly make the high side gate measurements. So this is our signal generator, the T3AWG. That generator has two modes. It has an AFG mode, and where we can output standard square wave, sine wave signals, and we have an AWG mode where you can make output arbitrary signals with sequencing and so on. And for that double pulse setup, we use the double pulse signal of the AFG mode. So you can firstly set up the carrier data, the frequency, how often your double pulses repeat, and then you can define your pulses. The first pulse with the amplitude, the pulse width of that pulse, you can control the rise and the fall times of your pulses, and the delay. Then the second pulse, the delay from the first to the second pulse, and also again the amplitude, so you can control each of these parameters individually. And then I have set that for a double pulse into burst mode. I want to output just one burst when I click the trigger button to make a new acquisition, to make one test, so that I don't have the stress all the time on my semiconductor.